Okay, so let us move on to 3.7, the solar panel function. So in this case, we have a little bit of a cartoon here from XKCD. It's a little bit of a joke. So it's basically asking us if we should put solar panels on something, so does it move around? Yes, no. If it doesn't move around, we ask if there is empty space nearby where it would be easier to put them. If yes, well, we should probably not put it on it. If no, we should probably, fine. It's fine to put something on something that doesn't, solar panels on something that doesn't move around. So for instance, should I install solar panels on a chimney? Then we can determine that using a function, and what the function is doing is basically we're giving it the answer to each of these questions, and then it should return the appropriate output. So in this case, we set it, well, the first move around is false, so it's no. The second one, this one is yes, that's irrelevant because we're in the no branch. Hot is true, so this one is true, but that's also irrelevant. And then empty, that's this phrase here, then that's true. So for chimney, it is false that it moves around, and it is true that there's empty space around a chimney where it would be more convenient because there is the roof. So in that case, it should say probably not, and that's what it's doing. Here's another example. Should we put solar panels on the roof, move around? This first one, move, is in this case false. The two other ones are irrelevant, and the last one is false because there's not really convenient place around a roof typically where it would be more convenient to install the solar panels. So in that case, it should say, sure, we can put solar panels on a roof. So that's how this function is supposed to work. So it's basically just testing these true-false statements. So let's try to implement that function. So it is here. You can see that it's given these values, and then it should make the determination. So in this case, we need to translate all of these values into appropriate Boolean statements, or into an appropriate Boolean statement, and make the right print statements. So let's start by doing that. So I think my strategy is going to be to notice that there are 4 different print statements that we can do. So let's focus on this one, sure. So print, sure. And we know we should do that in this case. So I'm just going to do that. I'm going to call the function like this and see if it prints out sure. So right now it prints out sure, but it's not supposed to print out sure all the time. So when are we supposed to print out sure? We're supposed to print out sure when move around is false. So if move, so we can test that like this, and the expert programmers are screaming a bit inside, but I'll explain why in a second. And then this one, empty, this variable is supposed to also be false. Like this. So in that case, we print out sure. We see that it still works. So why did I say that people were screaming around? Well, because we can actually just abbreviate it like this. Because these are Boolean statements. So if move is false, then not move is going to evaluate to true. So let's just actually confirm that. So let's say move is false, then not move is true. And on the other hand, if move is true, not move is then going to be the opposite value. So that's going to be false. So that's how the not operator works. So I can actually just write it if not move and not empty. And that's a little more elegant in many people's opinion. But on the other hand, maybe it's a little less explicit of what goes on. So it's completely fine if you prefer to write it like this. And now that I think about it, I think I'll actually stick to this notation here, even though we are supposed to do the other thing, because otherwise people will tell us that we look like novices. But I kind of like the verbosity now that I look at it. So let's try to do another one. So this one, it should say probably not. So I'm just going to comment this one out and focus on this case. So it should be probably not. like this. Okay, so when should that happen? That should happen if the first one is no and the second one is yes. And list says that it works, and it says probably not, so that works. However, it should also happen in this case, right? So if the first one is yes, and this one, swap, is yes, then it should also say probably not. So how can I do that? What I can do is that I can put a parenthesis here, just to be explicit about what I'm doing, and then I can say or move is true and swap is true, like this. And I put an or here because it needs to happen in either of these cases, like either if this is true and this is true, or if this is false and this is true. Both of these cases should say probably not. So now we sort of solved this path, we solved this path, we solved this path, and now we need to solve the last two paths here. Let's try to do that, and let's see if there's another example here. I like to just do the examples. So we take this one, solar panel on a windmill. So in that case it moves and some other conditions are met. Let's look at it in a second. So here we have the windmill. So what does that mean? The windmill moves. It doesn't have to recharge or swap batteries, so that's a no. Is it hot to the touch? No. So it should be maybe, and it prints out maybe. So when is that true? Let's do print maybe here. Well, it's true if move is false and this one is false, which was swap, right? The swap is this branch here, and this one was false, no. What was that called? It was called hot, the third input argument, this one, hot. So you can see it up here. Like this. That case print out maybe. The filter printed pressed go. Let's see, what happened here? Oh, wait a second, I did a mistake, right? I did a mistake. Yes, it's yes, I swapped around yes and no here. So it should actually say yes, move is true, right? It's the true branch. I'm just thinking no because it's to the left and I'm just accustomed to that, I guess. Actually, it's really mean because I think he changes around whether it's yes or no, right? That's really, really mean. It's super bad from a UI design perspective. But I guess that's what we get from a comic. So let's do the last one. Haha, good luck. So that is when it moves around, when it doesn't have batteries, and when it's hot to the touch. Then good luck. So if it moves around, if it doesn't have batteries that need to be swapped, and hot is true, then let's do haha, good luck. Okay. And we don't really have a test case for that. So I'm not just going to comment out all of these print statements, and then I'm going to do the tests here, just to see if I did it correctly. Maybe I did, maybe I didn't. I didn't. So let's see what happened here. So one of these were mistaken. So let's go to the test results and see what the problem was. Ah, I think I messed around here in UI. Here we go. it should print it out on 2 lines. So it's printing it out on 2 lines, I think. Let's just check that is actually the case. So here we have the test, so I can press here, and then I can go to the test that failed. Yeah, so it's a little bit obtuse. I think this test should be refactored, but we can see that we actually split this into 2 lines, and it's supposed to print it out in 2 lines. It should make a more verbose comment about what went wrong here. So actually it should print it out in 2 lines, not 1. Which kind of makes sense if you read the comment, I guess. Comic. So let's try to run it again now. Now it works. Okay. So I need to add a to-do. I think I'll Morten Vendrana, or I will fix that test, but it's just too late to do now. Okay. Anyway, now we got it correct. Let's see if we can do something a little bit smarter here. So usually when you have a lot of Boolean statements like this, you can typically simplify them a little bit. Because in this case we notice that this and this is actually the same, it's only this one that differs. So what we could actually do instead, if we could do this, if move is true and swap false, then what we could do is this. And then in this case, because if this is true, one of these must be true. In that case we can just ignore this stuff. We don't need to check that. So then we just look at hot. And this would be equivalent actually. So in that way you can actually also refactor all of these Boolean statements if you want. So there's a lot of different ways of solving this problem that kind of leads to the same place. Okay, so that was that problem. Let me move on, and I really hope that I get to something that doesn't have to do with print statements. It has to do with print statements. Okay, that time, that's all. So see you in the next video.